What do you do here?
Find common denominator.
Find a common denominator. What's your common denominator?
24.
24. Now, you can always get a common denominator by multiplying this number by this number, right? Okay? And something you knew how to do in 5th grade. And then they put a calculator in your hands and never ask you to do a fraction again. So, you know, it's a skill that you can easily master, and you need to master, okay? But it's not something at the level that we're going to teach in pre-calculus. But there is something that's really relevant to this course. I mean, just basic arithmetic is relevant. So we want to talk about this. So, your common denominator is 24. How are you going to put 1/3 in an equivalent form with the denominator 24?
Multiply both the numerator and the denominator by 8.
Yeah. So the 1/3, if multiplied by 8 over 8, is going to give us a denominator of 24, right? So that's going to do this. And it's going to be the same number. It's just going to look different, because you're going to get 8 over 24. Well, that's the same as 1/3. And you should know that. If you don't, you want to review some of these basic properties of arithmetic. And then with 7/8, we're going to multiply that by 3 over 3. And we're going to get 8 over 24 plus 21 over 24. Okay? Now, what people will often want to do here is add the numerators and add the denominators. That doesn't work at all. For many reasons, and you can look at the MCR videos if you need to see why. See how we can easily show that it doesn't work and can't work. Okay, now we have 8 over 24 and 21 over 24. So we have 8 24ths and we have 21 24ths. If you add 8 of something to 21 of the same thing, what do you get? You get 29 of the same thing, right? That makes sense? So we're adding 8 24ths to 21 24ths. We have to get 29 24ths. It wouldn't make sense otherwise, if you understand what a fraction is and what it means. But since it's something that's not well developed and not well taught in prerequisite courses, you probably want to give it some thought. Okay, so anyhow, that's how it's done. Now, if we had 5/6 plus 1/8. What's our common denominator? Well, 24 is our least common denominator, and that's the one we really probably want to use. We wouldn't end up with the wrong result if we used 48, 6 times 8. We could always use the product of these numbers, right? So I'm going to do it that way. So now I've multiplied both 5, 6, and 1/8 essentially by 1, right? 8 over 8 is 1, 6 over 6 is 1. And I'm going to get 40 over 48 plus 6 over 48, which equals 46 over 48. And what I need to do to 46 over 48? Got to reduce that to lowest terms. Divide numerator and denominator by 2, I get 23 over 24. Right? Okay? So it's kind of, you know, this just a review for most of you. You understand this. Most people need to have some kind of reminder if you haven't done fractions in a while. Okay? 5, 6 plus 1/8. 24 is also a common denominator, right? By that I mean there's an integer I can multiply by 6 and an integer I can multiply by 8, to give us 24, right, in each case. So I can do 5/6 times 4 over 4 plus 1/8 times 3 over 3. That gives me 20 over 24 plus 3 over 24. So now I have 20 24s and 3 24s. That's going to add up to 23 24s, right? That's 23 over 24. Same thing I got here, but this is a couple extra steps, and you got to realize that you got to reduce to lowest terms. It's really easier to get the least common denominator, but if you don't, it doesn't mean you're going to get the wrong answer. If you do all your steps right, you'll still get the right answer. Okay? So you got to know that. Okay. Now, how am I going to add those? Well, I have to have a common denominator. What's my common denominator going to be? Well, what can we always do? What did we do here to get the denominator? We multiplied the two denominators. Thank you. That's exactly what you were going to say. Sorry, I took the words out of your mouth, but you're right. Okay? Make sense? Well, so the common denominator is x minus 7 times x plus 4. Okay? Now, means I'm going to take x plus 5 over x minus 7, and I'm going to multiply it by some expression over the same expression. Then I'm going to add that to x minus 2 over x plus 4, multiplied by some fractional expression, right? And I have to get x minus 7 times x plus 4 in the denominator, don't I? So let's see, what would I multiply x minus 7 by to get this denominator?
X plus 4 over x plus 4.
I'm sorry?
X plus 4 over
Yeah, x plus 4. It's so obvious that most people don't even want to tell me that. All right, fool. What are you asking me that for? It's obvious, right? You can say that. Okay, x minus 2 over x plus 4. We have to multiply that numerator and denominator by something to give us this, right? And what had that something better ought to be? X minus 7, right? So we multiply by x minus 7, numerator and denominator. Okay? So now what do we have? We have x plus 5 multiplied by x plus 4 over x minus 7 times x plus 4. And notice I need these parentheses, right? If I don't have the parentheses, let's say here, the only thing that gets multiplied is the 5 by the x. Nothing else gets multiplied, right? Got to have the parentheses for that reason, and that's something I think most of you are aware of, but it's not an uncommon error to write things down carelessly. You'll even see me do it. Okay? So you want to be careful. Okay, so we get this. Now there's nothing in this that isn't implicit here, here, or here, right? We're just doing it with different expressions. They're not just plain numbers. Okay? Now we have to multiply these numerators out. How do you multiply x plus 5 by x plus 4? And don't tell me anything that starts with F. I don't want that F word in this class. It starts with F, ends with L, 4 letters, a couple vowels in between. Fool, right? F-O-O-L. Okay? How do you multiply x plus 5 by x plus 4? Using real rules of mathematics. What's the rule you use? Or the law? Talked about it last time. Did an example last time, at least one. You review your notes? Did you take notes? You aware of everything I said? Did you look at the videos? You don't want to do that if you can help it. Okay? You ought to be taking notes. You ought to know that I mentioned the distributive law. You ought to have maybe 10 words that remind you of the things that we talked about last time, right? That's what it means to take notes, not copy down what's on the board, which is going to appear on the assignments page anyway, right? You got to do that. Okay, please do. I want you to succeed. Okay, x plus 5 times x plus 4 is multiplied by the distributive law. Don't have a lot of room to do that, but I'll squeeze it in here. It's a little small, but you should understand what I'm doing. X plus 5 times x plus 4 equals what? By the distributive law of multiplication over addition, it's x times x plus 4 plus 5 times x plus 4. And then by the distributive law again, x times x plus 4 is x times x plus x times 4, right? Of course, x times x is x squared. X times 4 we write as 4x, and then we have 5x plus 20. And then 4x and 5x, we got 4 of them, we got 5 of them, we got 9 of them. So to get this numerator, I multiply this out, and that's what I get. And you have to be able to use the distributive law. I will test you over it. I will penalize it if you don't do it right, and without a lot of partial credit. It's absolutely necessary that you be able to apply the laws and know what the laws are, and along things like the laws of exponents and stuff that we'll be talking about more. So x plus 5 times x plus 4 is x squared plus 9x plus 20. Now, a lot of times, people draw a little arc here and a little arc here and a little arc here and a little arc here to remind themselves what to multiply by. Well, that's not the way the distributive law is stated. If you're going to do that, I want you to prove that it works by showing how that embodies the distributive law. Or you make a table. You put the x and the 5 and the x and the 4 here, and then you have x and x gives you x squared, x times 4 gives you, all that. Okay? I see that a lot. That's not the law. That's a shortcut. You have to be able to distinguish the laws. You have to know what the laws are. Because if you don't, you do what I see way too much of. Even by the end of the course, you misapply the laws. Okay? You do things that are not consistent with the laws. And it's an epidemic. There's way too much of it. Anyhow, be aware, and you'll see it in the assignments. I'll ask you, show me how you use the distributive law to multiply this. Okay? Show me step by step. Show me this. Right? It's not that complicated. You got to know that that's what the distributive law says. Okay, down here we get x squared minus 3x minus 28. Over here we get x squared minus 9x plus 14 over x squared minus 3x plus 28 minus 28. Okay? And of course this had better match this because this matches this, right? If you get two different things, then you got to go back, maybe refigure a little bit. Okay? And that equals what? Well, just like if you have 20 24ths and 3 24ths, you end up with 23 24ths, right? These are the same kind of thing. They have the same denominator. So you're going to just say you got this many plus this many of these things. A little vague, but just by analogy, you get this. Now, if you're working by habit rather than by rules and laws, which is the way you've been trained, the way the SOL system has things, everybody got to shortcut things. you end up doing mathematics by habit rather than by rules. This course is a transition from doing things by habit to doing things by rules. It's more than that, but that's one of the things you got to do in this course. You got to know what the rules are, and you got to know if you're applying the rules correctly or not. Okay? Because in any pre-calculus course prep in this country, people come in with very shaky algebra. Okay? And it gets in your way. You got to get it out of your way by understanding the distributive law and a couple of other things. Okay? And laws of exponents. Those are a couple of biggies. Okay, so you need to do this. But the advantage is it's not that hard if you practice with it. Okay? But, you know, we're going to emphasize that, so be aware of that. Okay, now, we have these, and we got an x squared and an x squared. What's that give us? If we have an apple and an apple, what do we have? 2 apples. We got an x squared and an x squared, what do we have?
2x.
Got a couple of x squareds, right? Which we write as 2x squared. Not as like add the exponent to get x to the 4th or something, and I see that. Okay, which is what I mean by shaky algebra. Okay? It comes out of our system, and you want to be careful. Okay? Okay, then we got a 9x and a negative 9x. Well, obviously that gives us 0, right? And a 20 and a 14 gives us 34. And there we've got our result. Okay? Now you might not be totally comfortable with this, but you know. With a little practice, you will be. First, you understand how you do fractions with numbers. Then you just do the same operations if you got symbols. Okay? You find a common denominator. You multiply both fractions by whatever it takes to give you the common denominator. And then you just simplify everything. Yeah?
Can you cancel out one of the x squareds?
What now?
In this one, can you cancel out one of the x squareds?
I'm sorry, again?
Can you cancel out one of the x squares? You have 2 up top and 1 up
No, you can't do that. And we don't cancel in this course. But thanks for asking, because I wanted to mention that. Okay? You don't cancel in this course. There's no cancellation. You don't cross things out. You do that by rules, and we'll talk about that. Okay? Because you'll want to do what you said there. You know, cancel this with this. You can't do that.
Well, I mean, like, you'd end up with just x squared plus 34 as opposed to just 2
No.
plus 34.
No, you can't do that either. This isn't added or subtracted from that. It's part of what divides this whole thing. Okay? So you can't do that. It looks like you could, and that's what I mean, not picking on you, because that's the kind of thing I see everybody do, okay? Or at least 90% of people come into pre-calculus. You're doing things by habit, by the way they look, instead of by the rules, okay? And that's why I mean we got to make that transition, okay? So I'm certainly not picking on you. I'm glad you asked, okay? But that's a question 90% of a typical pre-calculus class could well ask, okay? So there's something terribly wrong with that. And what's terribly wrong with our system is people don't understand that that's terribly wrong. And that's one of the things we got to do in this course is understand what's wrong with that, okay? So you can't do that. Now the rule you were given is you can divide out factors, which means you can cancel factors, but I don't allow cancellation. Because people will do incorrect calculations. They'll cancel this x squared with this x squared. They'll cross out this 2 and this 2. Okay? They got a 3 here, so they'll cross those out, and they'll end up with 4 over x. Okay? Not that bad, but just about. Okay? Every one of the things I said, I don't think people would cancel, would cross out this 3 and this 3, but almost. Okay? It's almost that bad. Because, again, for the SOL, you just got to learn to cross things out. Okay? And don't bother checking it. and circle the number that you think is right. And you never learn the mathematics. You never learn how to do the algebra. And it's really important to be able to do the algebra right. So we got to fix that, but that works. People that do their work in this course generally do a good job of fixing that. Once in a while they slip up, of course they lose points, but not so often it kills them. Okay? You want to avoid those kind of slip-ups. Okay. So anyhow, that's a brief picture. You'll have problems to do for homework for Thursday that ask you to do these things. You have 40 minutes of video from the MCR class. You got this thing, which is already up to 20 minutes. Okay? And all kinds of stuff on the internet if you need it. But it's going to be very much like this. I'm not going to vary a whole lot. There's one more thing that I want to do to emphasize the distributive law. So, now that F word thing I mentioned, the two middle letters are O-I, okay? If it was O-O, it would be fool.
Are you talking about like foiling? Is that what it is?
I'm sorry?
Is it foiling you're thinking you're talking about?
Foil.
I didn't know how to say that word in here. It's a bad word. You get in big trouble if anybody out there hears it. They'll say we're saying bad words in class. Yes, that's it. Okay. So, avoid the bad words, though, and don't do that thing. Because it doesn't work here, does it?
No.
And where's the first to last? There's a middle. Doesn't work anymore. Why in the world do they even bother teaching it
So
if it doesn't work? The distributive law doesn't. Well, there is a point to teaching it, actually. And it's not something you want to use to multiply things. It's helpful when you're learning to factor. Okay? Very helpful when you're learning to factor trinomials. And factor trinomials is relatively important. So there really is kind of a place for it, but I forbid it because people try to apply it where it shouldn't be applied because people don't understand the rules. Okay? There's the distributive law. That's it. So I'm sorry, go ahead.
For this problem, would you take like the whole x plus 5 and distribute the whole thing? Or
You can. There are two ways you can use the distributive law here, and since you mentioned that, we'll do it both ways. Okay. One way is you can say this is x times x cubed minus 2x plus 7 plus 5 times x cubed minus 2x plus 7. Okay? Because you can distribute over this plus here, right? Or you could say this is x plus 5 times x cubed minus x plus 5 times 2x plus x plus 5 multiplied by 7. Right? In other words, this times this times this, and this times this. Okay? Now, this kind of tends to get things in what you might regard as a backward order. Okay? But it's all right. The distributive law still applies. X times x cubed. Okay, the distributive law here is x times x cubed, which is x to the 4th, plus 5 times x cubed, right? And then this is minus, I'm going to write it out, x times 2x plus 5 times 2x, but I've got to have parentheses for that minus. plus x times 7 plus 5 times 7, right? Okay? That's perfectly valid. It'll give you exactly the same result that this will. But generally, I'll choose to distribute over this one when I see an expression where this is longer than this one. Okay? Could be done either way though. There's no real preference. Okay, well then I multiply this out, I get x to the 4th minus 2x squared plus 7x, don't I? And I multiply through by the 5, that's a distributive law, I get 5x cubed minus 10x plus 7, right? And then I do the simplification. I've only got a single expression with x to the 4th, that's it, right? My x cubed expression, there's only one, there's a plus 5x cubed, right? Now there, yeah, right there. Now there's only the negative 2x squared. It's the only x squared expression, but there are two expressions with x. That gives me negative 3x plus 7. Now I could say more about it, but that's how it comes out, right? So I'm applying the distributive law to get from here to here. And then for each of these expressions, this one and this one, I have to apply the distributive law. Yeah? I'm sorry? I don't hear very well, I'm sorry.
At the end, you put 7.
Yeah, I did. 5 times 7, 7, isn't it? Wait a minute. I don't have enough fingers. What is it? Okay, well, it's 35. And this should have been 35, right? Thank you. You do have to keep an eye on me. Sometimes I get careless. Just 'cause, yeah, I don't have as many neurons as I used to. Okay. Probably have as many, they just aren't connected as well. Miss little details. And if we do it on this side, it's always a good idea. We again have an x to the 4th plus 5x cubed minus 2x squared plus 10x plus 7x, uh-oh, something's wrong, maybe, plus 35. Oh, I get it, this should be minus 10x, right? A little careless. I was just pretending to be careless just to demonstrate that sometimes it happens. See if anybody's paying attention, but since I already know people are, I'm going to have to watch my step. Okay, so now we have x to the 4th and plus 5x cubed minus 2x squared minus 3x plus 35. Let's see if this matches this. Yeah, it does. Okay? If it didn't, I'd have to go back and see what I screwed up. Make sense? You're looking at it like it doesn't match or something. Maybe that's not it. Okay, whatever it is, I think it works out. Everything looks like it matches up. The signs are right, the coefficients are right, exponents are in order. If it's not right, just fix it, okay? I think it's right. Well, that's a distributive law applied where that F word doesn't, right? So if you're stuck with that F word, you can't do this. Okay? So you got to know the distributive law.